Hello and welcome back. Let's finish up this question that we started in the last video. So we were looking at some course evaluations for female and male professors, and then the question was, is there a difference in the evaluations? So we were able to write down, say, the null hypothesis, which is that the course evaluations, the mean of the course evaluations are the same, but our alternative hypothesis, which was our claim, is that there is a difference. We were able to plug everything into StatCrunch and find the test statistic and the p-value, and we failed to reject the null hypothesis because our p-value was large. So we can say there is insufficient evidence I could write this morning evidence to conclude there is a difference. And I think that sort of finishes that question concerning the p-values. However, we could also construct some confidence intervals. And the one thing to keep in mind is that when we're constructing a confidence interval, we've got our normal distribution for the difference in the mean values. And this is going to be a two-tailed test because our claim and our our alternative hypothesis is that the two means are different from one another. So just because they're different, it means that we could either, one could be a lot smaller than the other, or one could be a lot bigger than the other. So our significance level alpha is then split into two on both ends, and our confidence level is just going to be 1 minus alpha, what's in the middle. So 1 minus alpha, which is 1 minus 0.05, is going to be 95. So we've got a 95% confidence level. So let's come back here, and we can go back into StatCrunch, into stats. We're using t statistics. We have two samples, and we have the individual data points in. So we can do this with data. Sample 1 will be our female professors, sample 2 will be our male professors, and we can do a confidence interval for these means, and we can do this at the 95% confidence level. We click compute, and it has computed everything for us. We can see that we've got our lower limit and our upper limit, and these will be our confidence levels. So let's round these to let's say three decimal places. So we've got negative 0.398, negative 0.398, and the difference in our two means is going to be somewhere between that number and 0.311. So in between a negative number and a positive number will be 0. So it is possible that these guys could be equal to 0. So our conclusion is that is the same. Because it is possible for our two means to be equal to one another. We do not have sufficient evidence to conclude that there is no difference in these means. So that's just going through an example question using our p-values and our confidence intervals to conclude that within this sample that there probably isn't a difference between male and female course evaluations. So let's go through one more example. We take 36 cans of Coke, and we measure how much Coke is in there, and it turns out that on average there's a mean of 12.1 0.19 ounces of liquid in there, or at least maybe we measured it with a can. But then with the standard deviation, it was 0.11 ounces for the standard deviation. We also did this for cans of Pepsi, and we found a mean of 12.29 ounces and a standard deviation of 0.09 ounces. So there's less variation, and they were slightly heavier. So it looks like the Pepsi cans were slightly heavier. So can we conclude that there's less Coke on average than Pepsi? So let's go through and write a few things down. So our claim is essentially what we're testing right here, which is, is there less Coke? So our claim is going to be there is less Coke in a can than Pepsi. And sort of symbolically, if Coke is going to be, if the mean weight of a can of Coke is going to be mu1, and the mean weight of a can of Coke or a can of Pepsi is going to be mu2, what we are testing is whether or not mu1 is less than mu2. And again, our null and alternative hypotheses, the null hypothesis is just going to be that mu1 is equal to mu2. The null hypothesis is always that these guys are equal. And the alternative hypothesis is going to be that, it's going to be our claim. It's just going to be that mu1 is less than mu2. When we do this in StatCrunch, we want to be a little bit careful. So it normally writes things as one minus the other one. So if we write mu1 minus mu2, if they're equal, then that should be 0. But if I take mu2 and move it to this side, I'll have mu1 minus mu2 is going to be less than 0. So this is going to be how we'll input this into StatCrunch. Our significance level is 0.05, just like the last question. It's quite a common significance level to use in science, although that may be changing. People may want a little bit more exact. And now we need to calculate our test statistic and our p-values. So let's input our data into StatCrunch. So if we come back to StatCrunch, we've still got the last question up, but it doesn't matter. We can come into stats. We are using t-statistics because we are testing population means without the standard deviation. We have 2 samples, and now we don't have the individual data points. We don't have the weights of every can. We only have the summary. We know the sample means, standard deviations, and sizes for both of them. So we have 36 cans of Coke and 36 cans of Pepsi. So our sample sizes are both 36. For Coke, we had an average of 12.19 and a standard deviation of 0.11. So 12.19 and deviation of 0.11. And for Pepsi, we had 12.29 and a 0.09 standard deviation. 12.29 and 0.09 standard deviation. So that's all of our data, and then we can perform our hypothesis test. So again, our null hypothesis is that the difference in the 2 means is 0, and our alternative hypothesis is that the difference in the means should be less than 0, specifically meaning that the average, the mean weight of Coke is going to be less than the mean weight of a can of Pepsi. And we can just click compute. And we've got all of our values up here. So the first thing to notice is the t-statistic. So let's round this to 4 places. So we've got 4.2216. So this is negative 4.2216. And then we can write down our p-value, which in StatCrunch, it doesn't even, it's so small that it just writes it that it's less than 0.0001. We don't really need it to be that exact. If it's that small, it's going to be less than 0.0001, which that means that our p-value is a lot less than our significance level, which means that we can reject our null hypothesis. So if we can reject our null hypothesis, that means that we're going to accept our alternative hypothesis that the mean weight of cans of Coke is less than the mean weight of our of the cans of Pepsi. So the conclusion is that there is sufficient evidence to support the claim that, and then we just finish it, that there is less Coke and Pepsi on average. I'm paraphrasing a little bit here, but I think you get the picture. There is sufficient evidence to be able to support our claim, and then we just recite the claim. So that's all well and good. And now we just need to try the same thing with our confidence interval, and we'll see if we can get the same conclusion. So again, for our confidence interval, we think, okay, we're testing something that's going to be approximately normally distributed. But now we have our null hypothesis, or sorry, our alternative hypothesis, our claim, is going to be that mu1 is less than mu2. So this is not a two-sided distribution. This is two-sided test. This is going to be a one-sided test. We think that the what am I trying to say? That there's less Coke on average than Pepsi. Not that there is a different amount, but there's strictly less. So this is going to be our significance level, our alpha. But to construct a confidence interval, you have to give both a lower bound and an upper bound. So we make it symmetric by putting that same alpha up here. And what happens in the middle, if I take alpha away from the left and alpha away from the right, what's left is 1 minus 2 alpha. So if I take 1 minus 2 alpha, alpha was 0.05, so 1 minus 0.05 twice is going to be 0.90. So 100% minus 5% and 5% gives 90%. So our confidence interval is going to be 90%. So we can come back to StatCrunch. And again, we go into our t-stats. We have 2 samples, and we only have summaries of the samples. We input our sample mean, our sample standard deviation, and our sample size for both, that was 0.11, and 12.29, 0.09, and this sample size of 36. Let me quickly make sure that those are correct. 12.19, 0.11, 12.29, and 0.09. Yep. And then, rather than performing a hypothesis test, we perform a confidence, we construct a confidence interval, and our confidence level is going to be 0.90, because it's a one-tailed test with a significance level of 0.05. And we construct everything, and we click compute, and it does it for us. So let's write down our confidence interval. So let's round it to 3 places, 0.140, 140, and negative 0.606. And what we notice is that because this is between 2 negative numbers, this cannot be equal to 0. and therefore we can reject our null hypothesis.